My name is Kevin Kwan and this is Physics 1 Lab for Oscillations. The purpose of the lab was to analyze and model the motion of a spring mass system in which the mass swings in an arc while also oscillating on the spring. It was also to plot and observe the energy change in the system for the predicted motion. The model included mass attached to spring oscillating and computational model provided in GlowScript. Fundamental physics principles included Newton's second law and energy principle. The system includes the spring, mass, and earth, and there weren't any surroundings. From the findings, we found that the x-axis motion is very similar with the expected and the actual model. The y-axis motion for the expected model in GlowScript has higher displacement than the actual model, and the change in total energy of the system is equal to zero. Newton's second law states that the rate of change in momentum is equal to the vectorial sum of forces on a body. The formula is F net is equal to the change in momentum over change in time, and from Newton's second law, we can derive the velocity update and the position update formula. The energy principle states that the change in total energy of the system is equal to the work done on the system by the surroundings plus thermal energy exchange between system and surroundings. In this experiment, there is no surroundings, so work and the thermal energy is both equal to zero, which means the change in total energy of the system is also equal to zero. It also states that energy is neither created nor destroyed, but it can be transformed or transferred. There were three types of energy in this experiment: translational kinetic energy, gravitational potential energy, and spring potential energy. This is the tracker video showing the motion of the oscillation. So initial conditions from the pre-lecture video, we found the mass, spring constant, and relaxed length of the spring. From tracker, we found the time interval is equal to 0.095 seconds, and the total time was 9.497 seconds. The initial position was found using the first point on the tracker, and the initial velocity was calculated using final minus initial using the first two time intervals. Here, every initial condition was updated accordingly, including mass, position, and velocity, delta t, gravity, spring constant, and relaxed length of the spring. Here, the energy formulas were updated accordingly, and here is where the while loop here's the while loop that shows the motion of the oscillation and how energy changes during oscillation. The force of gravity was set to negative mg in the y direction. Force of spring was set to negative spring constant times the distance times L hat, and F net was set to force of gravity plus force of spring. The velocity and position was updated using the velocity update and position update formula. And down here is where delta K, delta UG, and delta US is calculated. The change in gravitational potential energy in red and spring potential energy in green oscillate in a sine graph in opposite signs, indicating energy is periodically exchanged between these forms. The kinetic energy in blue also oscillates but with a different phase compared to the potential energies and is also less in magnitude. The total change in energy is zero, but the forms of energy within the system still change. The x position versus time graph shows that the model in GlowScript is accurate at predicting the actual motion. The y position versus time graph shows that the model in GlowScript shows a slightly higher displacement for the y position compared to the actual motion. Possible sources of error include rounding errors because the CSV file rounded all decimal points to 3 places, calibration and human errors when tracking in tracker, and air resistance and friction forces were not accounted for. The energy principle was satisfied because the total sum of all forms of energy, which were kinetic, gravitational potential, and spring potential, at any point during the motion was equal to zero. For the oscillations, oscillation of x position was found to be 1.615 seconds, and y position was found to be 1.519 seconds. The difference between the two was 0.096 seconds, and this can be caused by air resistance, error in tracking center of mass, and the motion not possibly not being perfectly in two dimension.